I'm just gonna have to do one that can also be worked with synthetic division. Because there's only one more problem on there that's gonna work out like this, that has a quadratic in it, and I want y'all to do it for homework. So, what time is it?
Oh, excuse me.
11:52.
All right, thank you.
Dang.
Yeah.
Here we go.
So,
This class is going about fast.
let's go and look at 2x, look at number 16. 16 is 2x squared plus 7x minus 3. Over what? X minus 2, okay. Dx, thank you. Alright, so in this one right here, again, I'm going to go long division with you. And then over here, I'm going to say 14,276 divides into
I'm sorry, where'd you get that?
126,374,510. All right. Now, when you attack this problem right here without a calculator,
Don't
what
do
is the
that.
first thing you do for the purpose? Not put it away. All right. What is the first thing you do? Huh?
You find where it goes in one time, right?
Yeah, you try to break it down into pieces, right? You don't think about this whole 142,000. You start thinking about in terms of the 14 into the 12. Well, that doesn't work, but 14 does go into 126, right?
Sure.
So we're looking mainly at 14 into 126. Now that may not give us the number that we want, but it's going to give us a good starting point. Well, we're going to use that same approach here. I'm not going to try to divide all of this into all of this. I'm going to just take this x and think about how many times it goes into the 2x squared. So, x times what is 2x squared? 2x. And I'm going to put the 2x, I'm going to line up all my x terms in a column. That is not the way I was taught, but it's the way I kind of taught myself as far as organizing things are concerned. This is sign language for organizing things. So, 2x times negative 2 is negative 4x. So again, it goes in that 4x column. And then 2x times x squared is 2x squared. Now, in the case of long division with polynomials, these two numbers have to be exact. Over here, it probably won't be exact. All right, so we get to this step, and just like if we had done the division here, our next step would be to subtract.
Right.
Well, that's what I'm looking at here. I'm going to subtract here, but when I'm subtracting with polynomials, that just means I'm distributing a negative within it. And one thing I also do whenever I do these problems, I never cross out anything. I never put a slash through my plus and make it a slash through my minus and make it a plus or anything like that. Because if I go back and double check my work, I'm going to forget, did I bring that down? How did that get there? So I always just do it above in parentheses or use a different color to do it. Just helps me know what I'm doing here. So 7x and 4x is 11x. And then, of course, this better be 0, and it is. So just like here, now I get this step here, and I get something here, and I subtract and get something here. What's the next thing I do?
Bring it down.
Bring down the next term, right? Well, I'm going to bring down the next term here. All right, so x times what is 11x? 11. So again, this is going to be lined up in my constant column. 11 and negative 2. Negative 22, 11 and x. All right. Now again, I get to the point where I'm subtracting. So minus plus. Negative 3 plus 22 is 19. So it's plus 19 over x minus 2. What might have helped in that last problem, let's look at it again. The last one we did was synthetic division. It was x squared minus 5, right? And then what went over here?
X cubed minus 4x squared minus 4x plus 20.
It might have helped if you'd put a 0x term right there. Just again, for the purposes of lining stuff up. So in this case right here, we were saying x squared times what is x cubed? So I would put that here to line up my x values. And then multiply x times each one of those. I didn't show that, I said it, but I should have shown it. Alright, so here we have our new problem as being 2x plus 11 plus 19 over x minus 2 dx. So what is the antiderivative of 2x? X squared. 11 plus 19 times the natural log of x minus 2 quantity plus c. It's about to say quantity squared. Are we okay here? And again, because the derivative of this was just 1, I could go straight to that. If this had ended up being 2x minus 2, then, or 2x minus something, then I would have needed to use substitution. I would have had it would have ended up being 19 halves of whatever.